I'm going to pick back up on slide 11. I'm going to take a look at these. These are called algebra tiles. The green ones are algebra tiles. The little yellow ones stand for just the number 1. So what we're going to do is write some algebraic expressions to combine these, okay? So I can see from the first set, this set right here, that represents 2x's, the coefficient 2, plus 4 constants, or 2x plus 4. And this set here represents 3x's plus 1, 2, 3, 3 individual constants, or 3 ones, okay? But what we want to do is combine these. So when you combine these, you don't think of them as being separate entities. You could just look at the number of greens that you have. Just looking at the tiles. 2x's plus 4 plus 3x's plus 3, that's a 3, equals 1, 2, 3, 4, 5x's. Or you can simply look at the coefficients. The coefficient of that x is 2. The coefficient of that x is a positive 3. And look at the sign in front, please. So 2x's plus 3x's make 5. You can add the coefficients, or you can simply look at the tiles again. 1, 2, 3, 4, 5. And then as far as the constants are concerned, are the ones. 1, 2, 3, 4, 5, 6, 7. So I have 5x's plus 7, or you can simply look at the constants. The constants, and I don't mean to do that in pen. The constants here, plus 4 and plus 3. Both of them go to the right for the constants. So we know 3 plus 4, 4 plus 3 is 7. So with that being said, we know that 2x plus 4 plus 3x plus 3 simply equals 5x plus 7. And that's that. You can easily look at tiles and put them together. All right, on the next slide, take a look at the first set of constants and coefficients, or x tiles you have. That represents 2x plus 3. The next set is simply 3x plus 1, 2, 3, 4, 5. And the last set is simply 2x's and no constants. So you have several like terms here. You have your 2x's, three more x's, and they're all positives, or they all go to the right. So 2 plus 3 is 5. 5 plus 2 is 7. 7 x's. Or you can simply look up here and count your x algebra tiles. 1, 2, 3, 4, 5, 6, 7. 7 x's. And then if we take a look at the constants, our constants are 3. Positive 3, which goes to the right. Positive 5, which goes to the right. And there's no constant back here, so we don't worry about that, okay? We just add the constants we have. 3 plus 5 is 8. So basically, 2x plus 3 plus 3x plus 5 plus 2x all equals 7x plus 8. You can look at these expressions in terms of x algebra tiles and individual yellow tiles. So you add or subtract, or you can just look at the coefficients in front of your variable expressions or variable terms and look at your constants, the direction on them, to tell whether to add or subtract. All right, so we're going to do this without the towels. It's very simple. And I just want to go through a few things. I want to make sure we understand what terms are. Terms are separated by plus or minus signs. So every time you can separate an expression by a plus or minus, that equals a term. Like terms are going to be the same variables, same exponents, or corresponding exponents. Coefficients are the numbers directly in front of should stay in front of the variable. And coefficients include the sign directly in front of the variable, guys. All right, so I'm going to answer this question first. This will be question 1. How many terms do I see? So I'm going to draw dotted lines before every plus or minus sign. So I can see that the terms equal 1, 2, 3, 4, 5. There are 5 terms. How many different variables? Basically, when I say how many variables, how many different ones? Well, I see an X, I see a Y variable, and I see a K variable. So that's 3. 3 different variables. All right, I'm going to list the coefficients in order from left to right, okay? So the first coefficient is 3. The next one, guys, will not be 4. It will be -4 because if I were to rewrite this as addition, it would be 3x minus the plus, and 4y will go to -4y. Minus would go to plus, and 3x would go to -3x. Plus 4k would stay. Minus would go to plus, and 3x would go to -3x. So basically, the coefficient for 4y, for the y term, that second y term is -4. If it's easier for you to rewrite it as all addition, and fine, rewrite it as all addition. But what I normally tell students is just to look at the sign in front. If it's a minus sign, your coefficient is actually negative. If it's a plus sign, your coefficient is actually a positive, okay? Easiest way to remember it. So since there is a minus sign, my coefficient is actually -4, guys. So look at that. So I would put not 4, but the first coefficient is 3. Sorry. The second coefficient looks like 4, but since there's a minus sign, I'm going to write it as -4. Because again, minus can go to plus, and the term afterward could change to its opposite if I were to rewrite these as addition. So I'm just showing you that that's actually a -4y, plus -4y. All right, it looks like the coefficient here is 3, but the sign in front is a minus, so I'm going to say the coefficient is -3. The fourth term has a coefficient of 4, and then the fifth term has a coefficient of -3. Catch the sign in front. Again, if it's minus, look at it as a negative. If it's plus, look at it as a positive term. When I say negative term, I mean it has a negative coefficient. That variable attached to it has a negative coefficient. Or the number attached to the variable is negative. Okay? This one, if it's a positive term, it means it has a positive coefficient. All right, are there any constants? Don't put zero. Zero is a number. So if you put zero, tell me the constant is zero. There are none, actually. And let's simplify this thing, okay? So I don't like to have all this written up above it. So to simplify it, I'm going to combine like terms. When it says simplify, basically it's telling you to combine like terms. The terms got to have the same variables, and those variables have to have corresponding exponents. But I'm going to go ahead and separate them again with my little before every plus or minus. So I'm just going to look at the terms. I'm going to go back and label term 1, 2, 3, 4, and 5. So I'm going to look. I know term 1 matches term 3, and it matches term 5 because they each have an x variable. Okay? With an understood exponent of 1 above the x. All right, so I have 3x minus 3x minus 3x. But I will tell you that these two are opposites. They cancel each other out, and I'm left with negative 3x. You could have said 3x minus 6x is simply negative 3x. Just up to you. If you say it right, left, left, they both go to the left, that gives you negative 6x. Totally up to you, okay? Now, I'm going to also take a look at some other matches. Well, term 2 doesn't match anything, so I write it back down. And term 4 doesn't match anything, so I write it back down. Now, you can write these terms in any order you want to. I really don't care. Just get the sign right, whether it's a plus or a minus, because if it's a plus, it indicates that the term is positive. If it's a minus, it indicates that the term is negative. All right, how many terms here? So I'm just going to draw lines. I'm going to go ahead and put an understood coefficient of 1. It's 1, 2, 3, so I know it's 4 terms. Again, that should be variable. How many different variables? Well, I see an x, I see a y, so I only see 2 different variables, guys. The coefficients, I'm going to list them in order from left to right. So let's get started. Okay, what is the coefficient of the first term? The coefficient of the first term is positive 3. The coefficient of the second term is positive 2. The coefficient of the third term is a negative 1. And of course, the coefficient of the fourth term is positive 4. So those are my coefficients in order from left to right. There are no constants on this one either. And I'm going to simplify by combining any like terms that I have. So term 1 matches term 3 and term 4. 3x minus 1x plus 4x. Right, left, right. That gives me 7x minus 1x, which is 6x. So 6x, term 2 doesn't match anything, so I just put plus 2y, and I'm done. All right, let's go on to the next one. Okay, hold on one second. All right, now if I had some constants, let me put something like this on here. Suppose I would have had plus 5 minus 8. Then I would have taken the positive 5 and the negative 8. That goes right and that goes left. And I would have put behind this minus 3. But that's only if you have constants. And I would have had constants. My constants would have been 5. And don't put 8. You would have to put 5 and negative 8. Because this is really 5 plus negative 8, guys. Okay? That's what it really is. Minus can be changed to plus, and 8 can be changed to negative 8, helping you to see that that constant is really negative 8, okay? So again, very important when you're listening to these things to catch the sign in front. If it's a minus sign, treat it as a negative number or negative coefficient. If it's a plus sign, treat it as a positive number or positive coefficient when you're listing them, okay? Okay, let's take a look at 4 more examples. So all I'm going to do is simplify these. So I'm going to give you a minute. You pause the video and write all 4 down and leave some space. And unpause it and then we'll get started. All right, this is what you should have. Start off with number 1. We'll call this one, that's the first term, second term, third term, and fourth term. I will tell you that term 1 matches term 3. Both of them go to the right. 3x plus 4x is simply 7x. And then we see that term 2 has a y. Term 4 has a y. Both of these go to the left, so I'm going to add those. That gives me, add the coefficients, that's negative 9y. So the entire expression simplified is 7x minus 9y. I'm going to call this one number 2. And draw bars to separate, put an imaginary 1 for that coefficient. That's term 1, term 2, term 3, and term 4. I will say that term 1 matches term 4. They both contain the variable m. Both of them go to the right. 10m plus 1m is 11m. You could have started off with the ends first. In other words, you could have started off with term 2 and term 3. It doesn't matter. Term 2 matches term 3 because they both have ends and they both go to the left. So negative 8 minus 7 is negative 15n. And that is the simplified expression for the second example. For the third example, I'm just going to draw my bars again. This is my terms here, 1, 2, 3, term 4, and term 5. Let's look at some like terms. If you like color coding, if you have colored pencils, instead of boxing in or circling like I did up here, you can actually color code. Term 1 matches term 5. So I know that this goes left. And this one goes right. Negative 2y plus 3y is simply 1y, or you could just write y. Doesn't matter. And then we see that term 2 is a constant. Look at it as negative 6. Term 4 is a constant. We'll look at that as negative 2 because it can be written plus negative 6 or either plus negative 2. Both of those constants go to the left. So that's negative 8. And term 3 doesn't match anything, so I'll write it back down. Again, they can be in any order. You could have written 7x plus 1y or 7x plus y minus 8. Or you put the negative 8 first. If you put the negative 8 first, you put negative 8 plus y plus 7x. I don't care. Just get the sign right in front. All right, let's take a look at what I'm going to call number 4. 1 term, 2 terms, 3 terms. All right, all of them have A's and B's. But so since they all have A's and B's and they have exponents, I have to check to make sure that the exponents match. So above this A is an exponent of 1, and above this B is an exponent of 2. Is there anything else that has an exponent of 1 for the A and an exponent of 2 for B? Okay, so that would put term 1 matching term 2. Term 3 does not match anything. It's all by itself because the exponent for A here is not a 1, it's a 2. And the exponent for B is not a 2, it is a 1. So term 3 is kind of the black sheep. It doesn't match anything. So right now I know that term 1 matches term 2. And that's simply going to give me, that's to the right, and that coefficient is -7. 3 minus 7 or 3 plus -7. Either way you look at it is fine with me. 3 minus 7 or 3 plus -7. They're the same. It's going to give you -4 and keep your exponents exactly the same. When you combine like terms, don't ever, 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 ever change the exponents. So you're going to change the exponents when you do the next lesson, okay? But for this lesson, which is combining like terms, don't ever do it. Don't ever change the exponents when you're adding and subtracting coefficients. And the term that doesn't match here is term 3, and I'll just bring it down. These do not match because I got AB squared, and the other one, I have A squared B. This is my final answer. All right, pause the video and write this one down. You can even try it on your own if you would like. All right, I'm going to separate these using bars for every plus or minus. I'm going to put my imaginary 1. I'm going to list it as term 1, 2, 3, 4, 5, 6, 7. This thing has 7 terms. Whew, okay, let's get started. All right, so term 1 has x to the second, y to the second. There's x to the second, y to the second. So term 1 matches terms 3. All right, let's go ahead and knock that out of the way. There are no other matches for that, okay? That's to the right, and -7 or -7 is to the left. So it gives me -3x squared y squared. Remember, we're not changing exponents when we're adding or subtracting coefficients. Okay, so let's see what else matches. I got a constant here. There's a constant there. So term 2 matches term 7. Could have put my constants together. You could have put your constants last. A lot of people do their constants last. It really doesn't matter to me, though. Okay, 3 to the right, 3 minus 12. 3 minus 12 is the same as 3 plus -12, which is just -9 or -9. Okay, let's see. Does term 4 match anything? Yeah. Term 4 has y to the second power, and term 6 is y to the second power. So that +1 matches that negative. Well, +1 and -5 are going to go together, or -5 for my coefficients, okay? So 1 to the right and then 5 to the left. That's basically the same as 1 minus 5 or 1 plus -5, which we know produces -4, but don't forget your variable and your exponent have to go back. Now, like I said, lots of people like to write that constant of -9 last. It's totally up to you. I didn't even have to put that -3x to the second power, y to the second power first. Just, again, make sure you get the signs right. All right, pause the video and try this one. And this is what you should have. Term 1, 2, 3, 4, 5, 6, and another 7 terms. can tell you that term 1 is H, is going to match term 4, which has H, term 6, which has H. And let's go ahead and look at those coefficients. Coefficient for term 1 is 5. The coefficient for term 4 is -3. It goes left, or -3. And then the coefficient here is -7 or -7, which also goes left. So I already know I have 5 minus 3. This is for the H's. 5 minus 3 minus 7. Basically, that's 2 minus 7, which is -5. So it's -5, and put your H back. All right, let's take a look at the x to the first, y to the second. X to the first, y to the second. So term 2 is going to match term 7. Now term 2 goes to the left, and term 7 will go to the right in terms of the coefficients. The coefficient for term 2 is -2, and term 7 is +3. That's just 1. So that's +1, and then x, y to the second power should go behind it. And I will tell you already that these are constants, and 4 plus 6 is just a constant 10. And that takes care of all of those. Again, you can have them in any order, just get the sign right. All right, on slide 18, it tells us to write an expression for the perimeter of a rectangle. Make sure it's simplified. So perimeter means the sum of all sides. And since it's a rectangle, all sides would mean all 4 sides, because there are 4 sides to a rectangle. So I tell you, if this side is 3x, then this side is also 3x. If this side is 6x minus 6x plus 5, this side is also 6x plus 5. So now I have all 4 sides labeled, and I can add all the sides together. The expression that I'm going to write is 3x, which is side 1, added to 6x plus 5, which I'm going to call side 2, plus 3x, plus what's labeled on side 4, which is 6x plus 5. That's the expression. And to simplify, all I need to do is combine like terms. That's it. One, 2, 4, and 5. Those terms match. And all of them go to the right. 3 plus 6 is 9. This 3 plus 6 is 9. Basically, that makes 18 x's. And then term 3 and term 6 are constants. So that's 5 plus 5, which is 10. So the simplified expression is 18x plus 10. And that represents the perimeter. Well, both of them represent the perimeter of the rectangle. It's just one of those expressions is in simplified form and the other one isn't. All right, it says your turn. I'm not going to make you do this. You're going to go straight to the homework. I didn't mean to put the answers on here, but anyway, you have homework attached. All right, your homework is like 5 problems, okay? And you're going to work on those, and we'll check those tomorrow. All right, thanks, guys.